Hello, my friends. Today we'll look at a challenging mouse puzzle about an airplane. An airplane flies in a straight line from airport A to airport B, then back in a straight line from B to A. It travels with a constant engine speed and there is no wind. Now, would the total travel time for the same round trip be greater, less, or the same if throughout both the flights a constant wind blows from A to B? I think this is quite a good puzzle for any high school student learning maths and physics. So here's what we will do. So you see we've got a plane and some wind. I think when we solve these puzzles, it's always a good place to start with a diagram to make sense of what's going on. So I'm going to copy the plane. We have a plane from airport A here, and then it will fly all the way to airport B. And when it's at airport B, right, it's gonna fly back because it's like taking a round trip. So airport B, and then flying back to airport A. So it tells us that the plane travels with a constant speed. So let's call the speed of the plane, let's call it P, right? P, that is I will use orange. That is the speed of the plane, okay? And we also call the distance from A to B, we call it D, distance. So D, that is the distance, and D, that's the distance, right? So let's think about how we can find the time given the distance and the speed. We know that speed is distance over time, right? Speed equals distance over time. So this means that time is distance over speed. So time is distance over speed. And in our case, the distance here is 2D because you go one way from A to B, then you go back from B to A. So that's 2D. And our speed, we have defined the speed of the plane to be the letter P. So 2D and then letter P. So this time is the time it takes the plane to make a whole trip when there's no wind. So let's think about what happens when there is wind. And here we're gonna add the wind image to the diagram like this. So like a wind blowing from A to B. So the wind is always there, even when the plane is coming back from B to A, okay? So let's call the speed of the wind W. So the wind speed is W, and I'm gonna highlight it into blue. So that's the wind speed, right? Now, for this problem, we assume there's no acceleration or deceleration. So when there's wind blowing the plane from A to B, then the overall speed of the plane becomes P plus W, okay? This is very important, right? We're gonna highlight that as well. Let's use yellow. P plus W is the speed it travels from A to B because the wind is helping the plane. And when the plane comes back from B to A, the wind is going against the plane. So naturally, the speed now becomes P minus W because the wind is resisting the plane. So we want to find the travel time again this time. And we really use the same principle, okay? It's distance over time, except we think of the whole journey as two separate trips. So let's consider the first part of the trip going from A to B. The distance is simply d, and what is the speed? Well, it's p plus w, right? So p plus w. And then the second part of the trip, the distance is also d. So distance, and this time the speed is p minus w. And we're really getting close to the answer now. So we do a bit of algebraic manipulation to try and make sense of the expression. So we factor out d, and then that becomes 1p plus w plus 1p minus w, okay? So what we do now is we have two different fractions with two different denominators. So we want to merge them together. So we have d, and then on the bottom is p plus w multiplied by p minus w. That's just the difference of two squares formula. That turns out to be p squared minus w squared. And on the top, for our numerator, we have p minus w plus p plus w, okay? So the w's are cancelled out, and then we're left with 2dp divided by p squared minus w squared. Now, we're gonna divide the whole fraction by p over p. So like this. So the top, we are left with 2d, and for the bottom, we are left with p minus w squared over p. And this is the important expression. Distance is 2d, and then the speed overall is p minus w squared over p. So let's analyze the two different times, right? So w squared is the wind speed, p is the speed of our plane. So w squared over p has to be a positive number, and minus that is a negative number. So that means our denominator here is always less than p, because a number is taken off p, right? So that means that our plane will always take longer time to complete the trip if there is some wind speed, even when, no matter how great the wind speed is, because there's one limit case we can think of, right? That is when the wind speed is as quick as the speed of the plane. So when w equals p, think about it here. If w equals p, then when the plane is making its first trip, it goes really fast, double its original speed. But when it's coming back, because the wind speed is so great, essentially the speed of the plane becomes zero, because p minus p is zero, so it stops moving. And the math checks out, because the time now becomes 2d minus p squared over p, which is 2d over p minus p, which is 2d over 0. That actually approaches infinity. And what that really means is, because the plane is stuck here, it cannot go back. So it's just stuck forever, and it's going to take an infinite amount of time before it can reach back to airport A. And that's it. That's our answer. How amazing. Now, if you enjoyed this video, please comment your approach, your thoughts, like, and subscribe, and I'll see you in the next one. Bye-bye.